Let z be a complex number with non-zero imaginary part. It means that z has finite real part and finite imaginary part. If this function is a real number, then what is the value of mod z square? If we uh, we know, if any function is real, then we know that its conjugate will have same value. Suppose that if a function suppose that if a function z is a real number, then its conjugate will have the same number. Okay, so here this concept will be used. So let me write the equation which we have to solve. It is 2 plus 3z plus 4z square upon 2 minus 3z plus 4z square is equal to its conjugate, which will be 3 plus 2z plus 4z square upon 2 minus 3z plus 4z square. This is the representation of the conjugate of any function. So let me give two properties which are going to be used here, which are: first one, that we take uh, uh, if we take conjugate of a number which is in a fraction, then the conjugation is going to open like this. Okay, and second one is that if we have summation of many conjugates like that, this type of uh, format if we have given, then we can write it as this also. Okay, so these two properties will be going to will be used here. So use these two properties here. 2 minus 3z plus 4z square, 2 plus 3z bar. I'm directly applying this property. First I have split this bar in numerator and denominator. Then I have split it like this. I have used this addition property here. So 3z bar plus 4z bar whole square. Okay. So again, denominator will also have the same case, z bar plus 4z bar. I thought this approach because they we can see that there is a difference slightly here, that there here is a minus sign here, but we have two positive here also two positive, here also two positive, here also two positive, here 4z square is positive, and here 4z bar square is positive, here 4z square is positive, and here 4z bar square is positive. So number of terms going to be cancelled here. That's why this approach came into my mind. So we have to cross multiply these two equation these two ones. So let's see what is going to happen is 2 plus 3z plus 4z square 2 minus 3z bar z bar plus 4z bar square is equal to 2 plus 3z bar plus 4z bar square plus 2 minus 3z plus 4z bar square. That's it. So we are now we have to multiply this. Let me take an observation that 2 into 2 will be 4 and here will also be 4, then it will be cancelled, so no need of writing 2 into 4. So 2 minus 2 into minus 3z bar, here also 2 into minus 3z, then this term will be come into consideration here. So we will write here minus 6z bar here, and you can also write here it will be minus 6z. So here will be 4 to the 8z bar square, and here also 4 to the 8z bar square. This term also will be cancelled. Again 3z into 2 will be 6z. Here 3z bar into 2 will be 6z z bar. So this term will be come into consideration. Okay. So again 3z 3 into 3 minus 9z into z bar. Here also the same term will become that 3 into 3 minus 9 is z into z bar. This term also will be cancelled. So I am multiplying uh, like this. I am multiplying these individual terms with this. Similarly, here also I am using these individual terms and using this mutually. So where I was okay. Minus 9z bar into z is not come is going to cancel. So we will not write here. Again 3z into 4z bar square. 3z bar into 4z square. Sorry, this is z 4z square. So this term will be come into consideration here. 3z, which will be 4z into z bar square. Here there will be 12 z bar into z square. Okay. So again 4 to the 8 z 4 to the 8 z square and 4 to 8 z bar square. Okay, this term will come into consideration here. 8z square plus 8z bar square. Okay, so again 4 minus 12z square z bar my z bar, this term also will be in consideration, which will be, sorry, here will be minus. So here there will be minus of 12 z square z bar, and here will be minus 12 z bar square z. Okay, here 4 z bar square z square 4 z square z bar square. This term is of no need. So let me take some terms. So let me simplify more here. It's minus 6z bar plus 6z 12z z bar square. Here also there is 12z bar square z they two will become as 24 z into z bar square plus 8z square minus z plus 6z bar. This term will also come in the right hand side. So this this will be 24z bar into z square plus 8z bar square. Okay, there is one mistake here. Since 8z square has been cancelled, so it will not be in LHS, and same here 8z bar square is also will be cancelled, so it will also be not here. Okay, so at last we have this type of equation, and taking LHS, taking the RHS part on the LHS, then we will have 12z minus 12z bar plus 24z into z bar square minus 24z bar z square is equal to 0. So let me take 12 common here. Here also there will be common z into z bar, and there will be z bar minus z 0. So we'll take here minus, then the common part will be same, z bar minus z. So we have two product forms, that minus 12 plus 24. Since this term can't be 0, equate to 0, because this will give us z is equal to z bar. It means to say that the complex number z has only real part, but we can see in the equation that it has mentioned here that the z has non-zero imaginary number. Okay, so if it has a non-zero imaginary number, then this is not going to happen. So this second part will be equated to be 0. 0. Okay, so we know that the z into z bar is equal to z mod of z square. This is a property of uh, complex number. So we can see here that mod z square will be equal to uh, 12 by 24 is equal to zero point 0.5. Okay, so we have answer here as 25 0 0.5. 0.5. Okay, thank you and have a nice time ahead.